So hello, I am Pyro Villanueva here to discuss a problem for the first problem set under the nonlinear equations function. So we have this problem. You have a spherical storage tank containing oil. The tank has a diameter of 6 feet and you are asked to calculate the height to which a dipstick 8 feet long would be wet with oil when immersed in the tank when it contains 4 square feet of oil. So we have here the figure of the tank containing oil. The equation that gives the height of h of the liquid in the spherical tank for the given volume radius is given by f of h is equal to h cubed minus 9h squared plus 3.8197 is equal to 0. So use the second method of finding roots of equation to find the height to which the dipstick is wet with oil. Conduct 3 iterations to estimate the root of the above question. Find the absolute relative approximate error at the end of each iteration and the number of significant digits at least correct at the end of each iteration. So we have this code here. It's quite simple. Here I did iteration code. So firstly, I made a function code for def, so I named the function iter just for iterations, and under it we have h negative 1 or h neg 1 comma h 0. I wrote first result is equal to 2 because I just needed a value higher than 1. So basically, while here in our iteration statement, while result is greater than 1, we will conduct this equation. So basically, this is the formula, the actual formula for the solution based off of the actual solution. So basically, we have here the 2 equations for. I just made it h up and h down because I needed it to be shortened so that it wouldn't pile up and make an error or something. So basically, it will be equal to h1. h1 will be our first iteration. So basically, we need a result that will be less than 1. So h1. Once we get h1, we'll then need to find the absolute value of h1 minus ho over h1 times 100. So basically that's a percentage. And then since we need that value to be translated to the next iteration, I equated ho to h neg 1 and h1 to ho. So basically it did the equation 3 times until it got a value lower than 1. So once we plug in the values we need, so at first we we let a value for h of 0 and h negative 1. So for h negative 1 we have 0.5, and for h of 0 we have 1. So now we have values for h negative 1 and h 0. So there you go. So since then, the while statement, it will repeat until it gets a value of result under 1. So we got here 0.847678. That's it.
Hello everyone, my name is Karla Malano, and today I'm going to discuss with you a solution to an engineering problem regarding differentiation using Python codes. For the problem, the velocity of a space rocket is given by t is equal to 200t minus 6. Calculate the jerk at t is equal to 10 seconds using a step size of delta t equal to 5 seconds using the backward difference approximation of the first derivative of v of t. In solving this using Python codes, the first thing we will be doing is to type def along with our chosen variables, given that Python code def is used in stating the function. So as you can see in our code, we assign cf as our variable for t and delta t. Thus, we have def cf open and close parenthesis t comma delta t. In the second, third, fourth, and fifth line, what we did is assigning of values to other variables we created. Variable t is equal to t, t1 is equal to t minus delta t, vt1 is equal to function t1, and vt is equal to function t. After this step, we can now generate our formula. So here in our code, we type result, which denotes the answer for our formula, is equal to Python code int, that will make the result a whole number, open and close parenthesis vt minus vt1 dash, which means divide, delta t. Also, we added Python code print, open and close parenthesis, double quote, vt is equal to 200t minus 6 in order to display the equation to the answer. For the last step, which we shouldn't forget, we input Python code return result in order to display the answer for the problem. Now, the code is complete, and as we run this, we obtain that a function of cf open and close parenthesis 10, 5 v of t, which is equal to 200t minus 6 is 200. Therefore, the velocity of the space rocket is 200 meters per second.
Hi, I am Leah Katrina from BSCE 3B, and I'll be presenting a hypothetical or real-world engineering problems using Jupyter Notebook. So for the part 3, integration, a little background about integration. Integration in mathematics is a technique of finding function g of x, the derivative of which dg of x is equal to a given function. This is indicated by the integral sign, as in integral of f of x, usually called the indefinite integral of the function. The symbol d of x represents an infinitesimal displacement along x. Thus, integral f of x dx is the summation of the product of f of x and dx. Under integration, there are several topics, and we chose trapezoidal rule of integration. So here's the problem. A company advertises that every roll of toilet paper has at least 250 sheets. The probability that there are 250 or more sheets in the toilet paper is given by the integral from 250 to infinite of 0.3515e raised to negative 0.3881 times y minus 252.2 squared, approximating the above integral as the integral from 250 to 270 of 0.3515e raised to negative 0.3881 times y minus 252.2 squared. Use single segment trapezoidal rule to find the probability that there are 250 or more sheets. So for the first step, type the problem in the markdown cells. Sunod, type the code in the code cells. Define mo yung function and input the variables of the given problem. Type mo na rin yung solution to the problem and return the answer or the value. For the first line, we use def drop open parenthesis a, b, close parenthesis. So, yung meaning ng def is a function defined. Def marks the start of the function header. So sa amin nga, def drop, yung function signature. Meaning, siya yung name ng function namin. And yung a and b naman, yung parameters. Yung parameters naman is yung variable listed inside the parenthesis of the function definition. In the next line, before we proceed inputting the variables from the given problem and typing the solution to the problem, first we need to put indentation. Indentation refers to the spaces at the beginning of the code line. Importante ito sa Python or sa Jupyter Notebook kasi ito yung nag-i-indicate na may block of code. Aside from that, we need a proper indentation para gumana yung code natin. After putting indentation, pwede na tayo maglagay or mag-input ng variables from the given problem. So, we name E for the exponent. And yung exponent is equivalent sa 2.71828. Next is A2. A2 yung pinangalanan natin for the next step solution. So, A2 is equals to 0.3515 asterisk or times E, tas double asterisk. Double asterisk means nagde-define siya as exponentiation operator. Negative 0.3881 times A, which is A is equivalent to 250 minus 252.2. Double asterisk ulit kasi nga exponentiation operator siya. 2. Same as B2. B2 yung pinangalan natin for the next solution. B2 is equal to 0.3515 times E, tas double asterisk for the exponentiation operator, times negative 0.3881 times B, which is 270. Equivalent yung B sa 270. 252.2 double asterisk ulit exponentiation operator of 2. Next is the result. Result yung pinangalanan natin sa last step ng solution. So, 270 minus 250 times yung sagot ng A2 plus yung sagot ng B2 times 10. Double asterisk ulit for the exponentiation operator of negative 54 divided by 2. Return result, ibig sabihin, yung return statement is used to end the execution of the function and return the result or the value. Yan, return result. Tapos yung name nung function natin, which is drop, open parentheses, A nga is equivalent to 250, comma, B is equivalent to 270. After typing the code, click the run, and the answer will be given. So the result is 0.537211605315645. Thank you.
Hi, this is Mohammad Maulad, and today we're going to discuss the ordinary differential equation using the Jupyter Notebook and Python. Okay, so in this topic we will be learning about the ordinary differential equation, or for short the ODE, and some of its application in the real world using Python and Jupyter Notebook. Okay, so what is an ODE? ODE is an equation that involves some ordinary derivatives of a function. Often our goal is to solve an ODE, for example, like how to determine the functions or what functions satisfy the equation. Okay, it is important for engineers and scientists to know how to set up differential equations and how to solve them. So below is an example of ordinary differential equation problem and solution. So we are using here the Runge-Kutta-Fort method in order to solve the ordinary differential equations. So problem 1, the concentration of salt in a homemade soap maker is given as a function of time by dx by dt is equals to 37.5 minus 3.5x. And they have given us the initial time, t is equals to 0. The salt concentration in the tank is 50 gram per liter using Runge-Kutta or fourth order method, and a step size of h is equals to 1.5 minute. What is the salt concentration after 3 minutes? So they are asking us what is the salt concentration after 3 minutes. So how do we solve this? First, the function that they have given us, we rewrite this in the form of f of t comma x is equals to 37.5 minus 3.5x. Okay, so for this problem, we will be needing this formula, which is the x sub I plus 1 is equals to x sub I plus 1 over 6 times the quantity of k sub 1 plus 2 times k sub 2 plus 2 times k sub 3 plus k sub 4, and then we multiply by h. Okay, so here the given is for I is equals to 0, t sub 0 is equals to 0, x sub 0 is equals to 50. Now we will be solving this in our coding in Jupyter Notebook. Okay, so we will be using the command def for defining our function f is f of t comma x. Okay, and then we just put our the given for our x sub 0, which is x sub 0 is equals to 50, h equals to 1.5, and then our formula in getting the time t, which is equals to h times 1/2, or h times 1 divided 2. Okay, So for our first part, based on the formula here, we have the x sub I plus 1. So in order to get the x sub 1, we must solve first for the x sub I. And the value of our x sub I is x sub 0, since I is equals to 0. Okay? We solve first for the x sub 0, and then we get and then we solve for the x sub 1. Okay? So in getting the iteration of x sub 0, we simply put the function they've given us, the 37.5 minus 3.5x. That's for our k1 times that to x sub 0. Okay? In order to get the iteration ng k2, 37.5 minus 3.5x, 3.5 times the value of x sub 0, and then we plus that to the quantity of 0.5 times k1 times 1.5. So what is this? Okay, so 0.5 is from our formula of in getting time, which is the h times 1/2, or 1 divided 2 is 0.5. We multiply that to value of h, which is 1.5, and we multiply that to our first iteration, or the previous iteration, which is the iteration k1. The same thing we do for getting the iteration k3. We simply replace the k1 to the previous iteration, which is iteration k2. Same thing with k4. In getting the iteration k4, we swap the iteration k2 to k3, the previous iteration, which is k3, in order to get the next iteration k4. Okay, now we can solve for our x sub 1, which is equals to, here in the formula, x sub I, which is x sub I is equals to x sub 0. So x sub 1 is equals to x sub 0 plus 1 over 6, and then times the quantity of k sub 1 plus 2 times k sub 2 plus 2 times k sub 3 plus k sub 4, and then we multiply that all to h. So this is the equation for our x sub 1. Now that we have solved for that, now we can solve for the value of x sub 1. Okay, so k11, we use the name k11 for our iteration for getting our x sub 1. Okay, the same thing that we did in getting our iteration in x sub 0, but this time is x sub 1, since in our formula we have the x sub I plus 1. So yeah, the same thing we did for the first part iteration. Here we simply, instead of x sub 0, we use the x sub 1. The same process that we did in previous iteration in getting the 4 iteration, and then we get the result here, x sub 1 plus 1 over 6 times the quantity of the first iteration, the k11, plus 2 times k21 plus 2 times k31 plus k41, and we multiply that all by h. And now to get our result, we simply use the command return result in order to get our answers. And we also print the function, or the f of 0, 50, or our f of t, x, which is t is equals to 0, and our x value is equals to 50. Okay, and we just simply put our unit, which is the gram per liter, in order to get our unit for our values. And we simply run that code out, and we get this 100, or we get the value of 11,455 gram per liter, and that's our approximate value of the concentration of salt at 3 minutes. Thank you.
So, good day everyone. My name is Andrew C. Silang from BSCA 3D. Today po is sasagot po tayo ng partial differential equation using the Jupyter Notebook na galing sa Anaconda. So, para mas lalo natin matutunan is ano nga ba yung partial differential equation? So, a differential equation, or briefly, PDE, partial differential equation, is a mathematical equation that involves two or more independent variables, an unknown function dependent on those variables, and partial derivatives of the unknown function with respect to the independent variables. Yung need po dito is hypothetical and real-world engineering problem. So, yung problem po namin dito is nanggaling din sa ginawa namin nakaraan. So below are some of the examples of ordinary differential equation problem and solution. So yung problem dito is, consider a steel rod that is subjected to a temperature of 160 degrees Celsius on the left end and 40 degrees Celsius on the right end. If the rod is of length of 0.1 meter, use the explicit method to find the temperature distribution in the rod from T equals to 0 and T is equals to 6 seconds. Use the change of x is equals to 0.02 meter and change of t is equals to 2 seconds and initial temperature of the rod is 20 degrees Celsius. So yung pinigay pong formula dito is k is equals to 54 W over M minus K and P is equals to 7,800 kg per meter cube and C is equals to 490 J over KJ minus K. So, una pong gagawin dito is makikita nyo po sa aming Jupyter notebook is yung mga given is sinulat. So, K is equals to 54, P is equals to 7,800, C is equals to 490, T is equals to 2, and X is equals to 0.02. So, dito po, sa problem na parabolic TD, so sinabi dito na since the explicit method is written as T sub I raised to J plus 1 is equals to T sub I raised to J plus lambda multiplied by T sub I plus 1J minus 2T sub I raised to J plus T sub I minus 1 raised to J. So, isa-solve po natin dito. Una, yung formula na nilagay namin sa Python which is lambda is equals to so K over P times C multiplied by T over by X raised to 2. So, yung una pong given dito is yung sinulat namin, yung T sub 0 is equals to 160, yung T sub 1 po is 20, yung T sub 2 natin is 20, yung T sub 3 natin is 20 din, yung T sub 4 natin 20 din, yung T sub 5 is equals to 40. So, yung T sub 0 po natin, yung 160, yan po yung yung boundary condition na binanggit. So, dito naman sa T sub 0 raised to 1 is equals to T sub 0. So, yan po yung yung 160 degrees Celsius na boundary natin. So, napansin yung T sub 1 raised to 1 is equals to T sub 1 plus lambda multiplied by T2 minus 2 times T sub 1 plus T sub 0. So, yung mga given po dyan, binigay, is nakuha. Then, yung nakuha natin na T sub 1 raised to 1 is equals to 29.88 degrees Celsius. So, ganun din po sa T sub 2 raised to 1. Sinubstitute lang po yan. Then, yung makukuha po natin dyan is 20 degrees Celsius. So, next po. Yung T sub 3 raised to, sulat ko na lang po para di malito. Yung T sub 3 naman po natin is yung sa computation po namin, kasi nakuha na po namin to sa problem namin nakaraan, is 20 degrees Celsius din po. Yung T sub 4 namin raised to 1 is 21.412. Then yung T sub 5 po natin na sinasabi niyang raised to 5 is equal to T sub 5 is equals to 40 degrees Celsius. So, ayun po yung boundary condition ng isa. So, ito po is yung mga nakuha po dito is ito na yung sa una, yung sa time is equals to 2 seconds. So, dito naman sa yung sa susunod po, yung T sub 0 raised to T sub 0 raised to 2 is ito na yung susunod na kukunin natin. So, ganun din po. Ang pinagkaiba lang yung temperature. For temperatures po dito is yung J natin is equals to 2 and yung time natin is nasa 4 seconds na and yung J natin is equals to 1. Yung nakaset po na J. O, tapos yung makukuha po natin dito hanggang dulo ay Yung una po, yung sa T sub 0 po natin, syempre, raised to 2. Ayan po lagi yung boundary condition natin, which is 160 degrees Celsius. So, yung T sub 1 raised to 2 po natin is yung 38.37 degrees Celsius. Then, yung sunod po, T sub 2 raised to 2 is equals to 20.70. Then, pagkataas po natin is yung susunod na po, yung T sub 3 raised to 2 natin is 20.10. Yung T sub 4 raised to 2 natin is equals to 22.62. Then yung T sub 5 natin raised to 2 is equals to 40 degrees Celsius. So napapansin niyo po yung T sub 0 natin is equals to 160 degrees Celsius, and yung T sub 5 po natin is laging nasa 40 degrees Celsius, kasi po ayun pong dalawa na yun yung ating boundary condition. So yung nakukuha, yung nagkakaiba lang po dito yung T sub 1, T sub 2, and T sub 3. So, dito naman po sa sa pangatlo natin is T sub 0 raised to 3 na po tayo. Kung mapansin natin, yung syempre po, yung sa T sub 0 raised to 3, lagi po yung boundary condition na nauna. So, 160 degrees Celsius po. Then, T sub 1 natin raised to 3 is susundan po natin yung formula which is given po doon sa problem namin, and in-input po namin yung formula dito, which is yan po, lambda multiplied by yan. Then yung T sub 1 raised to 2 po dito is 45.71. Yung T sub 3 naman po raised to 2 is equals to 21.91. Then yung T sub 3 naman po, T sub 4 natin is 23.67. And T sub 5 po natin raised to 5, which is the boundary condition, is 40 degrees Celsius. So, yung hinahanap lang po dito is yung T sub 0 raised to 3, T sub 1 raised to 3, T sub 2 raised to 3, and T sub 3 raised to 3, and T sub 4 raised to 3, and T sub 5 is equals to raised to 3. So, bakit yun po yung print natin dito, tapos yung iba pong sinolve hindi natin print? So, yung una po mapapansin yung mga po dito, solution is ginamit po para makuha yung mga hinahanap hanggang sa 6 seconds. Kung mapapansin niyo po sa tanong natin is nagbigay po ng initial temperature, then hinahanap yung hanggang T, yung time natin ay hanggang mag 6 seconds. So yung print lang po namin is T sub 0 raised to 3. Lagi po, di ba, yung boundary condition, automatic 163 degrees Celsius. Then yung T sub 5 raised to 3, boundary condition din po. So 40 degrees Celsius. So yung huli pong mga nakuha natin, mga naka-raised to 3 po is, nakalista dito is T sub 1 raised to 3, 45.72 degrees Celsius. Pag round up po natin is 45.73 degrees Celsius, 21.91 degrees Celsius. Yun naman po yung T sub 2 raised to 3 natin. Then yung isa po is T sub 4 raised to 3 natin is 23.68 degrees Celsius. Kung napapansin niyo po dito, medyo nag-focus po ako sa mga solution. Kasi po, kung mapapansin niyo po dito sa Jupyter Notebook ko po, ay wala masyado pong commands na ako ginamit. Yung medyo komplikado lang po dito is yung mga solution na ginamit, pero wala po masyadong special na code na ginamit. Kung mapapansin niyo po, in-equate lang po na ko yung given, then yung isa lang po dito na ma-highlight is yung print po yung sagot. Yun lang po.